magnets. Introduction. The purpose of this lab is in this lab, you will measure the distance dependence of the magnetic field due to a small bar magnet and compare your measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart law. Fundamental principles used in this lab. The magnetic field of a magnetic dipole when the observation location is much greater than the distance between the two poles of the dipole, and the power law relationship for a magnetic field due to a magnetic dipole. Computational model used. Produced a computational model in GlowScript using the experimentally determined value of the magnetic moment of the bar magnet to visualize the magnet's magnetic field and computationally predict what the magnetic field along the 45-degree axis of the dipole moment at some distance is. Assumptions made. The only magnetic fields that had a non-negligible value in this experiment were that of the Earth and that of the bar magnet. The magnitude of the magnetic field due to the bar magnet is proportional to some constant times some power of the distance. Preview of results. When applying our data to the power law relationship for a magnetic field, n was found to be negative 2.73 and k was found to be that long number. The magnitude of the magnetic dipole moment was found to be around 5.08 amps times meters squared. The computationally predicted field along the 45-degree axis differed from the observations, but not by much. Experiment and calculations. Here is us setting up the part of the experiment where we calculate the magnetic field 45 degrees to the dipole moment axis. And here is us recording or I guess not recording, but observing the magnetic field on axis of the dipole moment. In this experiment, the system was the magnet. And I'm not going to go too deep into the details of the experiment because we all did it. Here is the results of the experiment, our observations. And here is the graph of the natural log of the distance to the natural log of the x value of the magnetic field. And from this, we are able to find what n and k are, or the natural log of k, that is. And then we were able to plug in the natural log of k into some mathematical formulas to find what k is, and to find also what the magnetic dipole moment is. Also, it should be noted that our n value being found to be negative 2.73 makes sense because ideally negative 3 is the n value of the power law relationship formula for a dipole when you are calculating the field on axis of the dipole moment. Code. Here is here is the magnitude of the dipole plugged into the code along with the the function that was defined to do calculations related to the field given off by the magnetic dipole. And here's the results of the lab. As you can see, the magnetic field at the 45-degree angle at the distance we found is here at the bottom. Discussion and conclusions. Similarities and differences. The computed field along the 45-degree axis differed from the observations, but not by much. The observed x and y values were these two numbers respectively. I'm not going to read them out as they are long numbers. While the computational predicted x and y value were those two numbers respectively. Once again, not going to read them out because they're very long numbers. All these are in Teslas. All the observed and computationally predicted values were in the same order of magnitude. Possible sources of error. Any of the assumptions made for this experiment were not true and led to a significant difference in the result. Rewind the video to the assumptions made section for more details. Error in calculations, error in coding, human error when conducting the experiment. What if? If we hadn't oriented the experiment to compensate for magnetic north and had instead laid out the meter stick at some intermittent angle with respect to Earth's magnetic field, then Earth's magnetic field would have contributed to the X component of the magnetic field picked up by the phone, and our calculations relating to the magnetic field given off by the dipole would not have been as accurate. What if again? If we were to stick two identical magnets together end to end and run the experiment again, I would predict the measurements to double and the two combined magnets to act as one with double the magnitude of the magnetic field. Thank you for listening. Have a good day.